We're asked to determine if the following argument is a valid deduction rule. We have if P and Q then R, not P or not Q, therefore R. We will answer this question by making a truth table because the argument contains three variables. The first three columns of the truth table are P, Q, and R. Because we have three variables, it takes 8 rows to list all the possible permutations of true and false. From here, we have to have a column for each statement in the argument. For the next column, we have P and Q. Next, we have the first premise of if P and Q, then R. Then we have not P and not Q. Next, we have the second premise of not P or not Q. And then finally, we have the conclusion of not R. Notice how I've labeled the columns of the two premises and the column of the conclusion. And now to review the truth table. P and Q is true only when P is true and Q is true. Otherwise, P and Q is false. Looking at column 1 and column 2, notice P is true and Q is true in row 1 as well as row 2. In these two rows, P and Q is true. In all other rows, P and Q is false. Next, we have the first premise of if P and Q then R. The implication is false only when the hypothesis of P and Q is true and the conclusion R is false. Analyzing columns 3 and 4, notice P and Q is true and R is false only in row 2. This is a row in which the implication is false. In all other rows, the implication is true. In the next column, not P is false when P is true, and not P is true when Q is false. Similarly, not Q is false when Q is true, and not Q is true when Q is false. In the next column, we have the second premise of not P or not Q. Not P or not Q is false only when not P is false and not Q is false. Looking at the two previous columns, not P is false and not Q is false in row 1 and row 2. In these two rows, not P or not Q is false. In all the rows, the disjunction is true. In our last column, we have the conclusion not R. Not R is false when R is true, and not R is true when R is false. And now we can check to see if the argument is a valid deduction rule. For the next step, we determine the rows in which all of the premises are true. Notice both premises are true in row 3, row 5, and row 7. And now we check to see if the conclusion is also true in these 3 rows. If the conclusion is true in all of these rows, we have a valid deduction rule. If the conclusion is not true in all of these rows, we do not have a valid deduction rule. When we can see in row 3, when the two premises are true, the conclusion is false. And therefore we can stop here. We know we do not have a valid deduction rule. But if we continue, notice in row 5, the conclusion is also false. It's also false in row 7. So again, looking at rows 3, 5, or 7, in each of these rows, one will be enough. Both premises are true. However, the conclusion of not R is false. Thus, this is not a valid deduction rule. There is one more thing we might notice from the truth table. If we compare the columns of the two premises of if P and Q then R and not P or not Q, notice how the two columns are not identical, and therefore these statements are not logically equivalent. Remember, for two statements to be logically equivalent, the columns in the truth table would have to be identical. I hope you found this helpful.